Today we're moving forward on our demographic perspectives by focusing on IPAT, which is impact equals population time affluence times technology. However, before we get there, I'm going to place it in this doctrine in history. Remember, we have demographers or demographic concepts all the way throughout history. In our pre-modern doctrines, we have the Genesis, be fruitful and multiply. Confucius, governments should maintain balance between population and resources. Plato, population quality is more important than quantity. And Aristotle, population should be limited, abortion might be appropriate. Moving forward with pre-modern doctrines, Cicero believed population growth was necessary to maintain the Roman Empire. St. Augustine thought abstinence is preferred way to deal with sexuality, but the second best is to marry and procreate. And St. Thomas Aquinas said celibacy is not better than marriage and procreation. And although we do, as a matter of course, tend to focus on just Western worlds, also in 1380, we had Ibn Khaldun, an Arabic individual who said population growth increases occupational specialization and raises incomes. Mercantilism was increasing national wealth and depends on a growing population and can stimulate trade. And physiocrats of the late 1700s, early 1800s said that population size depends upon the wealth of the land, which is stimulated only by free trade. Of course, we focused on modern theories. Malthus, population grows exponentially, food supply grows arithmetically, poverty is the result in the absence of moral restraint. The neo-Malthusian focus of demographic perspective is that birth control measures are appropriate checks to population growth, and conversely, Westerners had some disagreements about that, as Marx and said each society has its own law of population that determines consequences of population growth. Poverty is not the natural result of population growth. When we start discussing the modern theories, including the demographic perspective, I would like to also remind you that during this time is when Esther Boserup was working on other aspects, but the demographic transition in 1945 in its original form was the process where a country moves from high birth and death rates to low birth and death rates. 1962 were when the earliest studies suggesting the need to reformulate the demographic transition theory. A lot of this was focusing also on the critiques we discussed before of activities such as war, but also cultural differences. And so in 1963, a lot of the demographic perspective had individuals decided to look at population pressures as determined by the means available to them to respond. Causes and consequences of population change are intertwined. Continuing through the 1900s, in 1968, Easterlin decided to focus on cohort size hypothesis, mostly based on the baby boom, where he said that as large young cohorts put pressure on young men's relative wages, it forces them to make a trade-off between family size and overall well-being. From 1971 forward, we went with a decomposition, which meant let's look at each of the demographic transitions separately: mortality, fertility, age structure, migration, urbanization, and family and household. When working on theories, you have to identify your framework. The framework is a way of thinking that lets us solve related kinds of problems. So Erlich, among many others, said, how do we make a difference? Let's look at a framework. And today's first quiz question is short response, because Erlich came at it from a perspective of what causes, and he did other ways as well, but this is what many of us are concerned with today, and that is what causes environmental problems and what can we do about it. Erlich focused on this idea: what affects the environment? he decided how many people, how many resources they use, and how the resources are used would be part of his framework. So one must consider, how do humans impact the earth? Barry Commoner in 1972 said, "The post-war technological transformation of productive activities is the chief reason for the present environmental crisis." With the expansion of cars, industries, and suburban living really had a lot of effect. Here we see factories having these large smokestacks. They're called smokestacks for a reason. How do humans impact the earth? It's not just air pollution. In 1972, Erlich and Holdren said, "If there are too many people, even the most wisely managed technology will not keep the environment from being overstressed." If you consider sewage and the number of factories due to the number of consumers, you will see a direct relationship that too many people, if not mitigated by technology, can be a problem. In 1972, Paul Ehrlich introduced an equation to highlight the significant impact of population on environmental issues. He intended it to refute the notion that population was a minor contributor to environmental crises. He said, in fact, population is, quote, "the most unyielding of all environmental pressures." His equation, known as IPAT, stands for environmental impact, population, affluence, and technology. As the world's population has grown significantly over the past 12,000 years, Paul Ehrlich's equation IPAT highlights how increasing in population has amplified environmental impact. His idea underscores that population growth is a major driver in environmental pressures, however, making it crucial to address its efforts to mitigate environmental crises. Essentially, as the population grows and consumption increases, the strain on the environment intensifies, especially depending on the technology employed. Considering this equation using energy and greenhouse gases, the environmental impact is equal to the number of people using energy times the amount of energy used per person times, in this case, the amount of carbon dioxide produced per unit of energy, because that is our technology. So, could you reduce the amount of carbon dioxide? You could reduce the numbers of people or reduce the growth rate. You could reduce the amount of energy used per person. In other words, you could conserve, or you could reduce the amount of carbon dioxide produced per unit of energy. Transitioning to cleaner energy like hydro, wind, solar, and hydrogen fuel cells can significantly cut down on carbon dioxide. By addressing these factors, we can make substantial progress in reducing our carbon footprint and mitigating climate change. Using an example of China's air pollution, there was an article in 2012, a news article, not a peer-reviewed article, titled "Air Pollution Kills More Than 8,500 People Across 4 China Cities." To understand what's going on, let's apply IPAT. The population is the number of people, the amount of resources used per person is the affluence, and technology is how the resources are used. Of the three variables, number of people, resources used per person, or affluence, or technology, which ones contribute to the I the most? While all three factors are important, technology often has the most immediate and significant impact on reducing pollution. By improving technology, China can and did make substantial strides in lowering carbon dioxide emissions and other pollutants, even as the population and consumption levels continued to grow. When Erlich was making this formula, and we'll think about it that way, originally the most basic could be impact equals population. The most basic formula. It assumes that all environmental impacts are due to population alone. That would mean the impact from 100,000 people has to be more than the impact of 10,000 people. However, we know that not all populations are alike, and this is crucial when comparing environmental impacts. For instance, how do we compare the United States with its 300 million people to India with 1.2? Both countries have vastly different consumption practices. To account for these differences, we introduce a new term into our basic formula, and that is A, affluence. This updated equation considers the variance in consumption practices. Affluence represents the amount of resources used per person. By including affluence, we can better understand the environmental impact on a per capita basis. This means that even if two countries have different population size, their overall impact can be compared more accurately by considering how much each person consumes. For the United States, we have 300 million population, and we average 7,164 kilojoules per person, which means that our impact is 2,149,200 kilojoules. If you look at India with a population of 1,200 million, and they use 565 kilojoules per person, so their impact is 678,000 kilojoules. From these calculations, we can see that the United States has a much larger environmental impact than India, despite having a smaller population. This is because the average energy consumption per person in the United States is significantly higher than in India. Again, this example illustrates how affluence, or resources used per person, plays a crucial role in determining overall environmental impact. Your quiz multiple choice question is, in the context of the formula I equals PAT, what does the term affluence A specifically refer to? When we look at population and affluence, these factors are relatively easy to measure. For example, P times A can represent the aggregate measure of total economic activity, such as the gross domestic product. This leaves technology as a sort of remainder in our equation. To isolate the impact of technology, we use the formula T equals I divided by P times A, where T represents the unit of the environmental impact per unit of economic activity. Essentially, it measures how efficiently or inefficiently resources are used and the resulting environmental impact. Let's look at water usage for the United States and India again. Again, we have the population being 300 million, this time times 4,500 gallons per person. And the technology here is how much water is reclaimed. 70% is not reclaimed, which equals we have 945,000 gallons. In India, the population is 1,200 million, and they use 1,000 gallons per person, and 90% of it is not reclaimed, which equals 1,080,000 gallons. From these calculations, we can see that despite having a smaller population, the United States has a significant water usage impact due to the higher per capita consumption and lower reclamation rates. Conversely, India's larger population and higher reclamation rates results in a different but still substantial impact. Throughout the semester, we will investigate this equation again, how the relationship between population size, affluence, or what is used per person, resource used per person, and technologies applied.